What if I told you there's a language that describes pretty much the entire universe? I'm not talking about English or Japanese, but a language that can explain everything from a tiny spark to a massive star. Well, today, we're going to learn the basics of that language, the language of chemistry. So think about it for a second. You see a brilliant, quick flash of light, a spark. How in the world do you write that down? How do you capture that intense, super fast chemical reaction on paper so that any scientist anywhere in the world can understand exactly what happened? It's a really cool question, and the answer is surprisingly elegant. Okay, so we could start by just describing it in a plain old sentence, right? When a magnesium ribbon is burned in oxygen, it forms a new substance called magnesium oxide. And look, this sentence is totally accurate. It tells us what we start with, magnesium and oxygen, and what we end with, magnesium oxide. But it's a bit of a mouthful, isn't it? A little clunky. Scientists knew there had to be a better, faster way. And that better way is the word equation. Instead of that long sentence on the left, scientists just write what you see on the right. Look how much cleaner that is. It's got all the same key information, but it's way shorter and gets right to the point. This is really our first step into speaking chemistry. So let's break down the grammar of this new chemical sentence. Because, yeah, it totally has its own rules and structure. But once you get it, you'll start seeing it everywhere. First step, we've got the reactants. Think of these as your starting ingredients. They're the things that are about to react and change. In our little spark example, that's the magnesium and the oxygen. And here's the key rule. The reactants are always written on the left-hand side of that arrow. And you guessed it, on the other side of that arrow, we have the product. This is the brand new stuff that gets created after the reaction is all done. For us, that's magnesium oxide. And the product is always on the right-hand side. So you've got reactants on the left, the arrow showing the change, and the product on the right. Super simple and clear. But you know what? We can make this language even more efficient. We can make it even shorter, and maybe more importantly, totally universal. It's kind of like creating a chemical alphabet that every scientist on the planet can read instantly. And we do that by using chemical symbols. So magnesium becomes Mg, oxygen becomes O2, and our product, magnesium oxide, becomes MgO. Just like that, we've gone from a long sentence to this super compact symbolic equation. This is the real shorthand scientists use every single day. Now, this looks perfect, doesn't it? Short, simple, universal. But there's a hidden problem here. This neat little equation, it's actually breaking one of the most fundamental laws in all of science. It's not telling us the whole truth. And to figure out why, we need to talk about what I like to call chemistry's golden rule. This is a law that every single chemical reaction in the universe has to follow, no exceptions. And here it is, the law of conservation of mass. All this really means is that you can't just make atoms appear out of nowhere, and you can't have them just vanish into thin air. Whatever number of atoms you start with, you have to have that same number of atoms when you finish. The left side and the right side of the equation must match. So let's do a quick head count on our equation and see if it follows the rule. On the left side, our reactants, we've got one magnesium atom. On the right, in our product, we've also got one magnesium atom. Okay, so far so good. But now look at oxygen. We start with two oxygen atoms on the left, but we only have one on the right side. Uh-oh, an oxygen atom has just vanished. That's not allowed. Our equation is unbalanced, and right now it's breaking that golden rule. So, what do? How do we fix this? Well, we can't change what the chemicals are, but we can change the amounts. We have to adjust the recipe, basically, to find that perfect balance and make our equation tell the truth. And voila! Here is the solution. This is the final correct balanced chemical equation. See those big numbers we added in front? The 2 in front of Mg and the 2 in front of MgO? Those are called coefficients, and they are the secret to getting this whole thing balanced. Let's count our atoms one more time with this new improved equation. On the left, we now have 2 magnesium atoms. And on the right, 2 magnesium atoms. Perfect match. Okay, now for oxygen. On the left, we still have our 2 oxygen atoms. And on the right, well, that big 2 in front of MgO applies to both the Mg and the O. So that means we have 2 oxygen atoms on the right as well. Everything matches, the law is satisfied, our equation is finally balanced. So let's just quickly recap the path we took here. We started with a simple description in words. Then we leveled up and translated that into the universal language of symbols. And then, for the most important part, we made sure our equation was honest by balancing the atoms to respect that law of conservation of mass. This equation, 2Mg plus O2 goes to 2MgO, is now what you could call a perfect chemical sentence. It tells the complete, true story of that little magnesium spark. And it leaves us with a pretty exciting thought. Now that you understand the basic grammar of chemistry, what other amazing stories about how our world works can this language tell us?